Okay, wonderful. So far what we've said is that good jobs are going to end up paying less than bad jobs, right? Workers are going to get compensated for unpleasant aspects of their workplaces. And that's a nice start, but most of these questions we're really interested in have to do with how market forces determine how pleasant or unpleasant a job's going to be. Right? If we want to think about how the gender wage gap is likely to evolve over time, and we know that on average women are more likely to benefit from flexible working hours than men, we want to know why it is that some jobs offer more flexible working hours, why some jobs offer less flexible working hours, and how that's likely to change over time, right, with changing preferences for workers or changing technologies. Right? Similarly, we want to think about why some factories are more likely to adopt safety equipment than others, right? What determines those decisions? So to think through this, right, think through this question of how the amenity levels of an occupation are determined, let's think about a really, really simple workforce, right? In particular, let's think about mall Santas, right? Dress up in the red suit, sit in the mall, have children sit on your lap and tell you what they want for Christmas. Yeah? And let's assume mall Santas, very, very simple preferences. They like money, right? They like getting a wage, but they dislike it when children tug on their beard, right? Which is a real occupational hazard in the mall Santa business. And I'll call beard poles B. Make sense? So essentially what we want to know is how markets are going to determine how many times an hour mall Santas have to have little kids pull on their beards. Cool. So let's start by thinking about which jobs Santas would or wouldn't take if they're given a variety of options. And we'll do this by thinking about how we can describe Santa's preferences over these two attributes of jobs, right? Wages and beard poles. So let's say I drew a graph. I've got wages, I've got beard poles. And essentially what I want to do is I want to represent the Santa's preferences, right? So I want to be able to graphically show which jobs Santas like better, which jobs Santas like worse. How am I going to do this? I'm going to do this the same way we represent anybody's preferences, which is to say I'm going to draw some indifference curves, right? That'll be able to tell me what's better, what's worse. Let's say, for a particular Santa, we've got indifference curves that look something like this. Got different wages, let's say $7 an hour, we'll say $15 an hour. And I've got different numbers of beard poles, right? Maybe this is 8 an hour, 10 an hour, etc. Cool? So let's think about what I'm saying. Oh, and I'll just throw out a couple points here. So let's say this is, call this point A, call this point B, call this point C. Right? So point A is when you're earning $7 an hour, don't get your beard pulled at all. Point C, maybe you get your beard pulled 5 times an hour, get paid $12 an hour, get your beard pulled 8 times an hour, get paid $15 an hour. Okay. So what are we saying when we draw these indifference curves? Well, the first thing you're going to note is that in contrast to many indifference curves you've seen in the past, right, known and loved before, these are sloping up rather than sloping down. So why is it sloping up? Well, let's think about what this means, right? What it means that it's sloping up is that I'm just as happy at a point like A, right, where I'm getting less money but getting my beard pulled less often, than at a point like B, where I'm getting more money and getting my beard pulled more often. Right? Why is that? It's because of the fact that money is good and beard pulls are bad. Right? So if I wanted to keep myself indifferent, I made my beard get pulled more often. The only way, or just picking anywhere, right? I get more money and I'm going to stay indifferent. The only way that I can be indifferent after getting something good is by adding a bad thing. Right? If we had downward sloping indifference curves, that would mean that I would be equally happy with more money and fewer beard pulls than I would with less money and more beard pulls, which doesn't make any sense. right? So it's sloping up because I've got one good and one bad. Now the other thing you might notice is that I've drawn these so that the slope is getting higher and higher and higher as my beard gets pulled more and more often, right? In other words, maybe I need $3 more an hour to deal with one more beard pull if I go from 9 to 10 beard pulls, but I would be willing to deal with one more beard pull for more like 50 cents an hour if I went from 1 an hour to 2 an hour, right? So why does that make sense? Well, remember, right, our slope is going to be our marginal rate of substitution. Which is going to be du dv over du dw, right? So this thing is going to get higher and higher and higher if the change in my utility with the change in beard pulls gets bigger and bigger and bigger, the more often my beard gets pulled. In other words, the reason that this is increasing with higher B is because the first time an hour my beard is getting pulled is less unpleasant for me, bothers me less than the 10th time an hour that my beard gets pulled, right? I'm more willing to tolerate small amounts of this annoyance than I am large amounts of this annoyance. This, by the way, is well justified with pain science. If you look at the research on nociception, which is essentially the sensory acknowledgement of noxious stimulus, you'll see that the more often you have, every time a noxious stimulus occurs, right, you get injured in a particular place, your nervous system becomes heightened in anticipation of being injured there again, right? So if I prick your finger with a pin the first time, if I prick the same spot with a pin a second time, you're going to rate the second as more painful than the first. Okay, cool. So this is all we're saying, right? And another way to think about this, sorry, just to prattle on at you a little bit, is with our normal downward sloping indifference curves, right? We say that you prefer averages to extremes. The same is true here, right? If I'm considering two choices like A and B, right? Where I've got no beard pulls and not a lot of money, or lots of beard pulls and lots of money, I'm going to say that I would prefer anything in between these two than I would these extremes, right? Wonderful, wonderful. Okay. Oh, and sorry, one last thing I want to do before I move on from the workers is define our MRS, right, which we said is basically du dv over du dw. What our MRS is always going to be telling us is essentially the change in the vertical good per change in horizontal good that will keep us indifferent, right? So in this case, this is going to tell us the increase in wage needed to compensate for an additional beard pull. Make sense? Great. Wonderful. So that's all we need to know to understand workers, right? This is telling us which jobs workers prefer to other jobs. It tells us how much you need to compensate a worker if you're going to increase the number of times that their beard is going to get cut. So now what we have to do, if we want to understand what's going to emerge out of a market equilibrium, is to think about the other side of the market, right? To think about what demanders are going to do, given a variety of options about how many times they're going to let their employees' beards get pulled and how much they're going to compensate, how much they're going to pay their employees. Right? Make sense? So let's simplify this by saying that for a particular worker, we're only going to worry about this one indifference curve here, right? The one we drew where we have these points A and B, right? The reason we're going to say this is, let's imagine that this is the indifference curve that represents the value of the worker's non-Santa option, right, or their outside option. So if instead of working as a mall Santa, they work as a cashier at a grocery store or something else, right, they do kids' birthday parties, they're going to end up being as happy as they would be with any job offer on this indifference curve. So now what we need to know is just, given that the employer could offer them any point on this indifference curve and get them to work for them, what's going to be the employer's preferred choice, right? Which option is the employer going to choose? So the simple answer to this is, we think that employers are motivated by profit, right? Their goal is to make as much money as possible. So all we need to know which compensation scheme is going to be preferred by employers is to know how much money employers can make with any given compensation scheme, right? So why don't I draw on here various combinations of options. That represent different levels of profit, right? So maybe this is going to be profit of $5 from hiring this worker, profit of $0 from hiring the worker, profit of -$5. Okay. So just as before, let's think about why I'm drawing these ISO profit curves so that they're sloping up, what it means that their slope is getting less steep as I increase the number of variables. Right? You can see the slope is steeper down here than it is up there. So first of all, why is it sloping up? Well, essentially because we're going to think that offering higher wages is going to reduce the profits of firms, whereas allowing children to pull Santa's beards more often is going to increase profits of firms. In other words, firms need to expend resources in order to prevent the pulling of beards, right? Maybe make the task of, or the experience of going and sitting on Santa's lap less fun by preventing the pulling of beards. So that's going to cost them money. On the other hand, they also don't want to have to pay their workers more, right? So increases in W cost money. Increases in B save money. Right? In other words, they increase profit. Make sense? Cool. Now the other thing is, right, why is it that I've drawn this so that the slope is getting flatter with higher B? Well, essentially what this is telling us is that the amount that I'm willing to pay in additional wages to get more beard pulls is less when I've got lots of beard pulls than when I don't have very many beard pulls at all. So this is going to make sense if I think that preventing the pulling of beards is relatively inexpensive when I'm preventing, the very, very large number of beard pulls, but it gets costlier and costlier and costlier as I get closer to totally eliminating the pulling of beards, right? So cheaper to prevent 10th beard pull than first beard pull. If we think about what this means in practice, right, we might think that all you have to do to cut down the number of times an hour Santa's going to get his beard pulled from 10 times an hour to 8 times an hour is just put a sign up, while people are waiting that says something like, please don't pull on Santa's beard, right? And then the most conscientious of parents are going to ask their kids not to pull on Santa's beard. The most conscientious of children aren't going to pull on Santa's beard. We've dealt with the problem in an extremely inexpensive way, right? If we want to reduce them further, we might need to have a helper elf, standing by to remind the kids not to pull Santa's beard just as they're getting on the lap, right? Or ask parents to stand right there and pull their kids' hands away before they pull on Santa's beard. All of this is going to increase costs, right? If we want to make it so that this never happens at all, right? Santas are completely beard pull free. We might have to tape boxing gloves onto the children before they get on Santa's lap, or have them, have a plexiglass barrier between Santa and the children, make Santa wear a motorcycle helmet, right? All sorts of things that are going to really reduce our ability to profit from our mall Santa business, right? So this is the idea here, where the cost of preventing beard pulls is going to be really, really high when we're preventing the last couple beard pulls, fairly low when we're preventing, when we're reducing beard pulls from a very, very high amount. Make sense? When I think about what this slope is going to represent, well, it's basically going to represent, right, the amount of additional wages I'm willing to pay in order to ask workers to tolerate an additional beard pull, which is going to be right? The slope is going to be the change in profit from a change in beard pulls over the change in profit from a change in wage, right? Amount willing to pay in wage to prevent a beard pull. Tolerate extra beard. Right? Whereas our MRS comes from our workers' preferences, right? This is going to come essentially from the firm's technology, right? It's going to have to do with the preferences of their customers, how rowdy the children are, how often they want to pull on Santa's beard. It's also going to come from the physical capabilities and creativity of management. Right? What strategies you have available to you that you could use to prevent additional beard pulls. This makes sense? That's basically this slope right here. Wonderful. And I'll call this, d pi db over d pi dw, marginal willingness to pay, just so we have a nice word for it, right? Okay, wonderful. So given all this, right, now we've characterized the preferences of our workers, we've characterized the preferences of our firms, right? We've got workers in blue here, firms in red. And another really important thing here, right? This direction is good for workers. This direction is good for firms, right? In an ideal world, firms would make their employees take as many beard pulls as the kids wanted to deliver and pay them absolute peanuts. Make sense? Whereas in an ideal world for workers, they would get paid absolutely enormous wages and never have their beards pulled at all. Okay. So now that we've characterized both sides of this market, let's think about what we expect to happen in equilibrium, right? What the market is going to determine as the optimal number of beard pulls and wages for workers to tolerate. So to start out with, we're basically going to be able to say two things about this. The first thing we can say, and this is the thing we can say with the most confidence, right, with the fewest assumptions, is that we should end up somewhere where the set of compensation schemes preferred by workers doesn't overlap at all with the set of compensation schemes preferred by employers. What do I mean by this? What I mean by this is, let's think about a possible compensation scheme like this, right? I'll call this A. At A, workers would prefer everything above their indifference curve, right? Everything above the indifference curve at A. And at A, firms would prefer everything above their indifference curve, right? Everything above their isoprofit curve. Everything in this direction from A. So what this means is, at A, right, if the firm was offering a compensation scheme A, they would be able to offer an equally good compensation scheme to their employees, right, something like B, that costs them less and is just as likely to be chosen by the employees as A, right? So there's no way that the firm's best decision is to offer compensation scheme A when they have some alternative that's cheaper for them and no worse for their employees, right? More profitable for them and no worse for their employees. So what this is going to tell us is we have to have a compensation scheme emerge out of negotiation between workers and firms, or out of market forces, or whatever it is that's determining levels of amenities, like this, what I'll call C. Right? Something where the set of options that are better for workers, the set that's better for firms, are completely non-overlapping, right? So optimal compensation to say no alternative. It's more profitable for firms. And no worse for workers. What this has to mean is that our indifference curve and our ISO profit curve don't intersect. Which is to say, right, that our MRS has to equal our marginal willingness to pay. Make sense? We've got to have a tangency here. And just to redraw this in a little bit less ugly way, right? In this case, we've got no intersection. We've got everything better here for the firm, everything better here from the worker. Nothing that's better for the worker is better for the firm and vice versa. Cool. So that's the first condition. This is going to be very helpful. This is something we can say is true anytime the worker and the firm are free to choose some sort of a contract with each other, right? As long as it's possible for them to vary the level of amenity that they offer and freely choose whatever they want, they're going to come to some conclusion where there's no way to make both better off. But this isn't sufficient to tell us what's going to happen, because there's a whole bunch of different combinations of amenities and pay that share this characteristic, right? We could have something like this, right? 5 beard poles and let's say $10 an hour. But you could also have something come out of the market that's better for workers and worse for firms, right? $15 an hour and 4 beard poles, let's say. Or something that's better for firms and worse for workers, right? Let's say $9 an hour and 7 beard poles. All three of these points, A, B, and C, satisfy the condition that there's no way to make the workers, no way for the firms to be more profitable without making the workers worse off, right? There's no compensation scheme that's more profitable for firms and no worse for workers. So which of these is actually going to happen in a competitive market equilibrium? The short answer is going to be what comes out of a competitive market equilibrium is going to be the compensation structure that leaves the firms earning zero economic profit, right? No economic profits, no economic losses. Let's think about why this has to be. Let's label this pi equals 0, right? This is when they're making no profits. This is better for the firm, so this will be, let's say, pi equals, extra $5 per worker. This is going to be worse, right? Pi equals -5. If we have a compensation scheme where employers are losing money, right, where they're making negative profit, employers are going to leave the market, right? They're going to say, my goodness, I'm worse off by hiring a mall Santa than I would be by having no mall Santa at all. Christmas is canceled this year. Make sense? So we can't have a compensation scheme where firms are losing money. How about a compensation scheme where firms are earning positive profit, right? If we had profits greater than 0. Well, in this case, the opposite would happen, right? If we had positive economic profits, firms that aren't hiring mall Santas would realize all the gains there are by hiring mall Santas. They would enter the market, increase demand for mall Santas, right, and force provide better alternatives for workers so that workers would be able to get a better offer than an offer on this indifference curve, right, and force the value of compensation towards a level where profits have to equal 0, right? So in a competitive market equilibrium, the only stable equilibrium is going to be where profits equal 0, right? So for any firms where we can negotiate our benefit level, this has to be true. And if we're competitive, we're going to have that profits are equal to 0.